Every car on the road relies on its brakes to stop safely. But how does a simple press on the brake pedal create enough force to stop a multi-ton vehicle almost instantly? The answer is the hydraulic braking system, one of the most important and reliable pieces of automotive engineering. In this video, we'll explain exactly how it works, why it's so effective, and why it's used in nearly every modern vehicle. A hydraulic braking system works by transmitting force using brake fluid. Pressing the brake pedal moves a piston inside the master cylinder. This pushes brake fluid through brake lines to pistons at each wheel. The wheel pistons then push brake pads against rotors or shoes against drums. The friction created between the pads and rotors or shoes and drums slows the wheels and stops the car. The brilliance of this system is that the small force from your foot gets multiplied. A simple press becomes a strong, controlled force capable of stopping a heavy car safely. Hydraulic brakes rely on fluid because it is incompressible. Unlike air or other compressible materials, brake fluid transfers force almost perfectly from the pedal to the wheels. This allows the braking system to work efficiently, consistently, and safely every time the pedal is pressed. The master cylinder is the core of the system. When the pedal is pressed, it moves a piston inside the cylinder, which forces fluid into the brake lines. Most modern cars use a dual-circuit master cylinder, which separates the braking system into two independent circuits. If one circuit fails, the other can still provide partial braking power, adding a layer of safety. Brake fluid travels through reinforced steel or rubber lines to the pistons at each wheel. These pistons push the brake pads or shoes against the rotors or drums. The brake fluid is specially formulated to resist heat and moisture, ensuring consistent performance even under extreme conditions. At the wheels, braking is achieved in one of two ways. Disc brakes use a metal disc called a rotor, which is clamped by brake pads. Disc brakes handle heat efficiently, making them highly effective for modern vehicles. Drum brakes use brake shoes inside a drum that are pushed outward by pistons, creating friction against the drum. Drum brakes are still used on some rear wheels but are less effective at dissipating heat than discs. One of the key advantages of hydraulic brakes is force multiplication. The pressure generated in the master cylinder acts on larger pistons at the wheels. Because these pistons have a larger surface area, the force applied at the brakes is far greater than the force applied at the pedal. This allows a driver to stop a heavy vehicle safely with relatively little effort. Hydraulic brakes are the foundation for several advanced safety systems. Anti-lock braking system (ABS) prevents wheels from locking under hard braking, helping maintain steering control. Brake assist detects sudden braking and increases hydraulic pressure for faster stopping. Electronic brake force distribution (EBD) balances braking between front and rear wheels based on load for better stability. All these systems rely on the fundamental principle of fluid transmitting and multiplying force. Hydraulic braking systems are reliable, but proper maintenance is essential. Brake fluid replacement. Over time, fluid can absorb moisture, reducing its boiling point and effectiveness. Brake line checks. Leaks reduce hydraulic pressure and pedal response. Brake pads and shoes, worn components reduce friction, requiring more effort to stop. Regular checks ensure consistent braking performance and safety. When you press the brake pedal, the pedal moves a piston in the master cylinder. Brake fluid transmits pressure to the wheel pistons. Wheel pistons push pads or shoes against rotors or drums. Friction slows the wheels and stops the car. Hydraulic brakes are simple in principle, yet extremely powerful and reliable. They're the reason vehicles can stop quickly, safely, and predictably under nearly any conditions. Understanding how hydraulic braking systems work not only helps you appreciate automotive engineering, but also highlights why maintenance is critical to keeping your car safe.